Okay, I think we shall make a start. Good morning. Morning, come on. Good morning. Yes, that's better. There we go. Late night? Yes. Yeah, oh dear. Uh-oh. A few bloodshot eyes. Oh well. Hopefully we can make it interesting, make it exciting, if there is such a thing, this morning. We're going to talk about virtualizing Exchange on Hyper-V. My name's Matt McSpirit. I am a senior product marketing manager working for Microsoft in the US. Actually based in the UK, the accent may have given it away, in the north of the UK, and where my team, Man United, just won the league, so I'm very happy. Looking forward to getting back this week. Boo, boo, security. I'm kidding. So yeah, this session is really about a little bit about Hyper-V in terms of performance, scalability, tuning, that kind of stuff, best practices, and then we'll focus on Exchange and how we can really help you drive forward with Exchange projects on Hyper-V and be confident in doing it. Exchange is one of those workloads, same as SQL, SharePoint, there's a little bit of trepidation about do I, don't I, should I, shouldn't I? And it's definitely a workload that can be virtualized very well and successfully if you follow the key guidelines. We'll go through some stuff around System Center as well and how that can enhance the story as well. So we'll look at a bit about why Microsoft virtualization in general for the core Microsoft Tier 1, Tier 2 applications like SQL, SharePoint, and Exchange. We'll look at some hypervisor-specific stuff, so why Hyper-V. Some tests that have been recently performed by Enterprise Strategy Group, and there's some great results in there that should validate confidence in putting workloads like Exchange on Hyper-V. Some best practices, and then some links as well, and we'll wrap up. So in terms of what's going on with the virtualization landscape, more and more workloads are being virtualized now. There's more and more confidence in the platforms, whether it's Microsoft, whether it's VMware, whether it's Citrix Xen Server, or even some of the open source options that are out there as well. Just by show of hands, how many people are virtualizing on VMware today? Fair enough. How many on Hyper-V? I think that was nearly double, actually, on Hyper-V. No, I'm kidding. Well, that's good. You know, how many people are doing both in their organizations today, Hyper-V and VMware? Okay, a fair number. And I think that just validates how much further we've come with virtualization now. It's getting more and more popular. And you'll see on that graph on the right, and this was similar to what was shown in the keynote earlier in the week, that physical shipments will still continue. Physical shipments will still continue to grow, but typically they're bigger, a lot bigger in some cases in terms of individual server size. Some of the workload tests we look at later on, some of the ESG performance results, they were running on servers with individual blades with 128 gig of RAM. Can anyone beat 128 gig of RAM in an individual server? Yeah, go on. How many? 192. Anybody else? Higher than 192? We had one guy in the session yesterday I ran on the VMware stuff, 512 gigabytes of RAM in a server. I had major server envy. My servers are very low spec compared to that, and I was crying a bit inside, actually. But you just see that it's more and more applicable now to populate these heavily dense servers with large numbers of processors, large amounts of memory. And as we scale up, that is why that graph of the blue lines, the virtual machines, the logical units, is growing so aggressively because we can consolidate more and more. On the left, you can see Windows still makes up the majority of server shipments. A little bit worrying about the unpaid Windows, 11%, but I'm sure we'll figure out a way to address that going forward. But still, Windows is the dominant force in that space. But why would you want to virtualize core stuff on the Microsoft platform? Why would you want to do that? Well, ultimately, Hyper-V, great platform for virtualization. Introduced in Windows Server 2008, enhanced in R2, enhanced again in Service Pack 1, and I'm sure it will continue to be enhanced going forward into vNext. I haven't seen any details about vNext just yet, of the next release of Hyper-V, but if you're like me, you'll be very excited about what's coming down the line, just in anticipation of what's going to be brought out. There's a lot of speculation, a lot of thought, but regardless of the rumors and stuff like that, I'm sure it's going to be a fantastic release going forward. And it is a very solid, scalable platform today. And then you put in on these key workloads, like SQL Server, like SharePoint, like Exchange. Some may be small deployments, individual mailbox servers and the other different roles in a smaller configuration. Some may go for much larger deployments for Exchange, SharePoint, and SQL. How many people are embracing cloud services for things like Exchange? Exchange Online, BPOS, those kind of things, so a few. So it's an interesting move. I mean, a lot of people are weighing up, the next release is, do we go down an on-premise route or do we go to the cloud? And there's a lot of pros and cons of both in terms of which route you choose. But certainly virtualizing those kind of workloads on Hyper-V is a great way to go forward. And then in particular with workloads like SQL as the backend for core enterprise applications, line of business apps, they can be virtualized on Hyper-V in confidence. We've got some great stuff now with SAP on SQL on Hyper-V, again, as part of this ESG testing that we've done. But it's really enhanced by System Center. And it was pulled out in the keynote. We talked about it in my session last night. System Center is really the key to unlocking the power in the virtualization estate, whether it's through monitoring of your key workloads, the stuff that's important, whether it's through backup and application protection, compliancy, configuration, service management, or automation. System Center provides all of those tools as a part of a unit, a single license suite, a single integrated set of tools that really can provide value at all those three layers. Hyper-V, even lower than Hyper-V, at the hardware layer, then Hyper-V inside the guest operating systems, and then into your line of business applications. And that's something that's quite unique to Microsoft in terms of the level of integration, but also the cost point at which you can acquire these technologies. The server management suite from the System Center family is, as I said, a single license, incredibly cost-effective way of acquiring all of those System Center tools. But it's not an all or nothing. You don't need to deploy every single System Center tool to get the value back. Tools like Operations Manager can provide significant value for Exchange in terms of monitoring it. Data Protection Manager for protecting Exchange, and SQL and SharePoint, obviously, as well. So we've got a great platform there, but that is Microsoft virtualization. So many people compare VMware and all the bells and whistles that it has as part of vSphere with just Hyper-V. And Hyper-V is our engine. It's our workhorse for these virtual machines. But the System Center tools are our brain in this environment, our management brain that's enabling us to do a lot more. And building on that, just look at the middle one, that complete management solution again, that deep application knowledge. How do you know when something's going wrong with a mailbox in Exchange or a transport or within the databases deep within SQL Server? That's where things like System Center really provide value. Whether it's physical or whether you've chosen to virtualize it, it doesn't matter. We can provide the same levels of knowledge and value. If you have embraced VMware today, that's fine. System Center can manage that as well. We've got a partner on the show floor, Veeam. I'm sure many of you are familiar with Veeam. They acquired NWorks, quite a while ago now, and they've now got a brilliant management pack for System Center Operations Manager that monitors and manages VMware. So if you're thinking about that whole stack monitoring view from hardware, through hypervisor, through virtual machine, through workload, even though it's running on VMware, there are partners out there and an ecosystem out there that can enhance tools that we have to deeply monitor those workloads on non-Microsoft platforms. So there's a good story there. In terms of Virtual Machine Manager in the System Center family, we now manage VMware, we manage Hyper-V, and going forward in VMM 2012, which is due for release at the end of this year, we manage Citrix Zen Server as well. So if you've embraced that, maybe for VDI or your server workloads, we can bring that into the family and start to monitor and manage in a coordinated way. And in terms of that partner ecosystem, there are some fantastic partners down on in the exhibition floor that are really starting to bolt in to System Center and Hyper-V. I was walking past the EMC booth yesterday, and they were doing a presentation. If you've not stopped by, definitely worthwhile. And they were talking about how System Center can monitor now some of the EMC storage and bring about nice changes with virtual machines based on changing conditions in the storage. So again, a great ecosystem building up. But ultimately, if you are virtualizing these core workloads on Hyper-V, you've got a single support statement right through the stack. You've got the workload, you've got the OS typically running on Windows, then it's running on Hyper-V. So a nice statement there for support. And it's a lower cost. As I said, that server management suite license that contains all of those System Center tools, license per processor. It's called the Server Management Suite Data Center Edition. And that gives you an unlimited number of System Center agents and tools for a particular host for, I think, $2,620 off the top of my head. So a very, very cost-effective way of acquiring those particular technologies, license per processor. Very, very cost-effective. But why Hyper-V? Well, is anybody who's running Hyper-V has put Service Pack 1 on their builds? Yeah, a few people. Excellent, brilliant. So Service Pack 1 introduced a number of new capabilities, but that just further enhanced some of the cool stuff that was already in Hyper-V. Live migration was included for free, so the ability to move workloads around with no interruption. HA, high availability. Again, if a node fails, workloads fail over to another node in that cluster. Again, a great story there. But that introduces new challenges, because think about Exchange and SQL and SharePoint. They all have high availability elements to them built in. SQL with its clustering, Exchange with things like DAGs now. You can achieve good levels of availability at the workload level as opposed to the hypervisor level. So there's a choice to make. Do I choose one over the other? How do I make that choice? What's best practice? And we'll go through some of that stuff later on. But some of the new stuff that was introduced, supporting the new processors that Intel AMD have released. Networking enhancements, very, very important for workloads like Exchange, where a lot of people are going to be connecting in over the network. That's got to be fast. That's got to be able to handle a lot of traffic. Has anybody deployed Windows in server core mode? Anybody there? Yeah, a few people. So if you're not familiar with what server core is a deployment option of Windows Server. So you've got your DVD, you've popped it in, you've booted it up, and you've got to the stage where you're choosing which operating system you want to install. And you've got standard enterprise data center, and then you've got standard core, enterprise core, data center core. And core is a smaller footprint, lower overhead version of Windows Server without a GUI. Okay, so it's a command line, effectively, deployment. It doesn't have all of the ticks that full Windows Server has, so all of the roles, but it has the majority. But you can't deploy Exchange or some of our key workloads on server core natively. Hyper-V is part of that, obviously. That's fine. You can deploy Hyper-V in core mode. And some of the stuff that was introduced in Service Pack 1, so dynamic memory allows us to more efficiently utilize memory in physical servers. Obviously, the chap last night that had 512 gigabytes of RAM, he probably doesn't need to worry about utilizing memory more efficiently because he's just got so much. But for the rest of us, it's an efficient use of memory is going to allow us to increase our density without having to add more physical RAM to the box just yet. And then remote effects was introduced, which is really around VDI and session-based enhancements from a graphics perspective. We'll look at some of some of the dynamic memory stuff later on. But when you're configuring Hyper-V as a platform for things like Exchange, SQL, SharePoint, there's a number of considerations you need to make. First up, you need to make sure that you're allocating enough physical memory left over for the actual Windows OS, the parent partition, as we sometimes call it. So the actual bare metal OS that's sat on that particular piece of hardware. Now it says here, plan for one dedicated NIC for management purposes, one NIC for live migration. There are certain documents out there that will say, yeah, that's fine. There are others that will say, you know what, I would need more than that. For me, I would say if you're using iSCSI storage, so network-based storage, I would say you would want a minimum of 8 NICs in a particular physical host. Okay, and the reason I would say that is you'll have a NIC for management, so that's for you to communicate with that host and manage it through monitoring tools like System Center and so on. So one NIC for management. One NIC for live migration, as it says. So it's a dedicated network when we're moving virtual machines around, nothing's going to get saturated in terms of that network by these live migration traffic. You don't want to combine all of these networks into one because when you're live migrating a virtual machine, it's flooding the network with traffic. The last thing we want to do is stop users being able to get to their mailboxes or their Outlook web access or whatever because we're moving stuff around. You want to separate these networks out. So one for live migration, one for management. Another one for cluster shared volumes, which I'll talk about later on. Another one for heartbeat, so for the cluster heartbeat. Okay, and don't be tempted to turn off certain things in the IP stack of that particular NIC for the heartbeat, because so many people get caught out with that based on previous versions of Windows clustering. Oh, I need a heartbeat network. Okay, I only need certain tick boxes on the NIC enabling, and that'll work fine. In 2008 R2, you want to leave some of those on. Now, when it comes to, so that's 4, heartbeat, live migration, management, and CSV. Then we start to get to storage. Now, if you're using iSCSI storage, you would want a minimum of 2 NICs for that with multipathing, because you want resiliency. And then finally, so we're up to 6, you would want at least 2 for your virtual machines. Okay, so the traffic that's going to be pumped out and in of those particular workloads. Now, I say a minimum of 2. In fact, I said a minimum of 8. In high-end workload environments where there's a lot of network I/O going in and out, you may want to extend some of those. You may want to introduce teaming. If you want to team and make resilient every single one of those networks, you're going to need double the number of NICs. Okay, so something to be aware of. So when you're specking up, if you're specking up servers going forward for virtualization and consolidation, you want to think about those kind of things. And there's some good guides on the web, but that's my kind of, I would say, a minimum of 8 if you're using iSCSI. If you're using fiber, you would need a minimum of 6 because you don't have those 2 networks for iSCSI. When you're separating stuff out on the storage, it is a good best practice to employ, obviously, RAID for data protection and performance, but this is standard stuff. This is how you would do it for a resilient data center anyway. But when it comes to the guests, the Hyper-V guests, when I create a new virtual machine in Hyper-V, I can use a dynamic virtual disk, which starts off very small. It's almost like I equate it to a buy now, pay later. So you get the virtual disk. It's very small, 0 megabytes. You install an OS in there, and it grows to the size of the files. You install Exchange, and it grows to the size of the files again, and you're up to 15, 16, 17 gigabytes in size. However, the performance isn't quite as high as what's known as a fixed-size virtual disk, which is a buy now, pay now, in terms of you say I want a 40 gig fixed VHD. On your SAN, you lose 40 gig of space. Simple as that. But the performance is that little bit higher. And in terms of Exchange as a workload, it will only be supported on fixed. Okay, so something that's very, very important. No matter what the virtualization platform, this isn't just a Hyper-V thing. So fixed, full-size disks are what we would support with Exchange. So I mentioned dynamic memory. Rather than talk too much about it, I just wanted to flick over to my little demo machine here. Here we go. There we go. And on my demo machine, I'll explain what's on the screen if it's a bit too small at the back. I've got a number. This is Hyper-V Manager, so this is what I'm using to manage my Hyper-V workloads built into Windows Server or downloaded for Windows 7. This isn't System Center, so I'm just using the kind of entry into the Hyper-V Manager. And what I've got here are a number of virtual machines, many of which have got warning or low, which isn't a great sign, but I couldn't have a perfect demo to show you. I've got to have stuff that's got alerting and so on and so forth. But you'll see here these 3 columns: assigned memory, memory demand, memory status. These were new in Service Pack 1. And assigned memory is really around what Hyper-V is given to this virtual machine at this point in time. And that is based on the demand from the VM, i.e. the guest OS is saying, I need this much memory, I need this much memory, give me it, please, please. And Hyper-V is saying, yeah, okay, there you go, there you go. But it's giving it that little bit extra on top, known as the buffer. You don't have to have much of a buffer. The default is 20%, but you may choose to just turn that off and give it what it wants. The beauty of this is, and if you look at some of my workloads here, these particular virtual desktops at this point, in fact, that's a Quest vWorkspace server, and that's a Quest virtual desktop. I've given them at this time about 1 gig, but actually the memory demand is only about 800 meg. But in some instances, what we're finding with some of these desktops, because they've got fluctuating demands based on users using the OSs, sometimes we need to give them a bit more memory, sometimes we need to give them less. So we can fluctuate between a minimum and a maximum for these VMs, which allows us to buy a little bit more, better usage of our memory that's available. However, workloads like Exchange, they're designed to take advantage of high amounts of RAM so they can increase the amount of I/O and the performance. So dynamic memory isn't really a technology that's suited to that. And the recommendation is to not use dynamic memory for workloads like Exchange, which is fair enough. You want it to be the highest level of performance reflective of the workload. When it comes to other workloads, like Windows 7 as guest or regular servers, file servers, and so on, and the majority of other workloads very suited to dynamic memory and integration with that. Okay, so I just wanted to make that aware. And in terms of the settings, if I go into the settings of this VM very quickly and look at the memory, bring it up, let me move this over here. So this is where I define all of the different settings of my my virtual machine. And you'll see that I've got a minimum, a startup RAM of 384 and a maximum of a gig. So this VM will have its memory fluctuating between that amount. Okay? And there's that buffer. Now, if this is a really important VM, maybe it's the CTO's virtual desktop, you think, you know what, I'm going to make you high priority because I'm after a raise. But if it's someone who you don't really like and you're their administrator, you think, nah, I don't really like you, I'll put yours low. So when there's contention, I wouldn't advise that. That's not best practice to pick on people. But in terms of what you're doing there is you're saying, in times of contention where perhaps all your workloads are suddenly spiking and they need more resource, the ones that have got high priority are going to get their RAM before the ones that aren't. Okay, so something to be aware of. But I just wanted to kind of walk you through and show you what dynamic memory looks like. But what we've seen from some of the testing is that dynamic memory has resulted in huge increases in density. So Citrix did some testing, and it was at TechEd EMEA in the keynote, where they showcased Zen desktop, virtual desktops running on Hyper-V, and a 40% increase in density, turning on dynamic memory. And Quest have got some similar tests as well that they've run, where they've seen excellent levels of scalability improvements, some in excess of 100%, so they've doubled, which is fantastic. So I'm not going to go through what it does and how it works. You've got an initial, a startup RAM, a maximum, and we just distribute that memory accordingly based on what the guest OS needs. But as I said, for Exchange, you wouldn't want to be using it, okay? And that's a recommendation from the Exchange team. So let me just flick through. So VMware have a similar capability if you're using VMware. So memory over commit allows you to set these minimums and maximums, and the memory will fluctuate between them. But they do introduce some other things around things like page sharing, memory compression, and so on. But with more recent operating systems, Vista, Windows 7, 2008, 2008 R2, the makeup of these operating systems, the size of the page tables, the things like address space layer randomization, easy for me to say. These kind of things make it a bit more difficult for these page sharing technologies to enhance performance and reduce the memory consumption. But certainly dynamic memory, very, very tuned to what the OS is doing and what it wants and needs at any time. So in terms of performance, why would you want to feel comfortable with virtualizing on Hyper-V? Well, things like the virtual reality check. You can download this, or you can sign up on the website and download the tests that they've done to validate key workloads on Hyper-V, Zen Server, and VMware. And the workload that they've tested in phase 1 and subsequently going on into phase 2 is virtualizing things like terminal server workloads. Now, terminal server, if you're familiar with it, quite a memory-intensive workload. It likes utilizing RAM to provide these sessions to different users. So it's a good representation of something that would utilize quite a lot of performance and capacity. But you'll see that what they found is when you're virtualizing workloads that are quite memory-intensive, like terminal server, if you run it on hardware that's got things like second-level address translation, in Intel's form, extended page tables, RVI, Rapid Virtualization Index from AMD. These are elements that exist on hardware that can offload from the hypervisor into hardware where it's faster, it's more performant effectively. And you'll see Hyper-V on that kind of hardware was flying along. 154% increase versus running it on non-SLAT hardware. Okay, so a great example. And so when you're investing in key technology and key hardware, think about these capabilities. All of them made an increase. Hyper-V's was most significant. Now, we've got to admit, when virtualizing without these capabilities, vSphere was that little bit better when virtualizing without hyperthreading. However, with hyperthreading, Hyper-V outperformed vSphere. Does that say, oh, you would never use vSphere for virtualizing X, Y, Z? Absolutely not. Not the case. All three platforms are very performant for virtualizing your key workloads. But then we come on to the 2010 paper very quickly. And this was just there to kind of validate, and we worked with the Enterprise Strategy Group. It was a Microsoft-sponsored paper. It wasn't comparing Hyper-V with X. It was just talking specifically about Hyper-V and how easy to install. And I think if anyone's deployed Hyper-V, it is very, very straightforward. It's part of the Windows OS. It's a tick box as part of Server Manager. Reboot, and you've got it going. Clustering, it's very, very straightforward, so you can build high availability very, very quickly. And if you do have tools in your environment to deploy Windows OSs quickly, like Windows Deployment Services or Microsoft Deployment Toolkit or System Center Configuration Manager, all three of those tools will deploy Windows Server very, very quickly from a network-based deployment. Live migrations in there to move virtual workloads around very efficiently with no downtime. But more importantly, compared with physical, Hyper-V is very, very, very close in terms of performance, native performance. So don't be afraid to virtualize on something like Hyper-V. You can download all the white papers. They're all available online for you to grab. And in terms of some of the overheads, so you look at some of the kind of transactional workloads or Exchange databases, file servers. In terms of those virtual hard disks I was talking about before, very, very close. Very close indeed. So very close to native performance. So again, don't be afraid to kind of go down that route. Again, some more kind of stuff on that. So I don't know why my little image has gone really small there. It's even hard for me to see. Ignore the image for now. This is relating to storage and throughput from the storage, which is important from an Exchange, a SQL, a SharePoint perspective, definitely. And what we're saying here is around the time of the launch of Nehalem, which was the Intel 5500 chip, what we saw is a big jump in performance for virtualization. But also 10 gig Ethernet was starting to get more popular. So starting to be able to send that massive amount of data down these network links. And when we hooked up a single server to an iSCSI SAN with 10 gig Ethernet, we saw 1 million IOPS pushed across that. And that was huge. When we connected a Hyper-V VM directly to that same storage, using iSCSI, using the guest iSCSI initiator, over 10 gig, we saw 700,000 IOPS pushed over that, which is an incredible amount for a virtual machine. So again, great performance. And again, more about that. The throughput, the performance is excellent and in line, very close to what native is doing. How many people today are utilizing fiber storage? Have interest. How many people iSCSI? That's interesting. Last night, it was more or less the opposite, actually. More people running fiber than iSCSI in the session I ran last night. It's interesting. The more and more organizations I talk to, iSCSI is becoming more and more of a discussion point because of the performance now with things like 10 gig Ethernet and the cost versus fiber and the way they can quickly and seamlessly integrate it into their current networking infrastructure. But more people are starting to talk about FCOE, so fiber channel over Ethernet. I'm sure if you go down to the NetApp booth or whoever, they'll talk to you more about that as well. But again, it's up to you. Hyper-V will work with both. But remember what I said before. Yes, quick question.
The second line there, you said there shouldn't be any significant concern around I/O for virtualizing Hyper-V.
Yeah.
But in the previous 2 or 3 scenarios where you talked about memory and features that you could turn on for Hyper-V,
yeah. From a dynamic memory perspective, from an I/O perspective, absolutely, yeah. But
if you put it all together, you've got a couple no's and maybe 1 or 2 yeses. So is there a concern?
No, not at all. We'll come to the Exchange-specific bits later on, absolutely. That's the kind of 2/3 of the session will be spent on the Exchange-specific. So we'll learn more about that. I'm just trying to introduce little tidbits about Exchange at the moment. But yeah, so far for Exchange, the only real thing that we advise turning off is the dynamic memory. But that's it, okay? So we'll look at some of the performance results for the key things that we've seen in terms of the ESG lab summary. And this is all available online. You can grab the link. You can grab it from Microsoft.com/virtualization. It's all there. But in terms of their server, and again, this is where I had server envy. So they're running 2 HP BL680s, 24 cores, 128 gig of RAM per blade. So this is the physical underlying infrastructure. And that's hooked up by fiber channel storage to 155 15K fiber channel disks. So pretty high end, and they split it out in terms of data, logs, OS, applications, in terms of that carving out that physical infrastructure. But we look at the virtual element, and what they've put together, they've separated the data and the logs, which is best practice if you were deploying in physical or virtualized. So they've separated those out. They've separated the virtual machine images in terms of the OS images out, and all on fixed VHDs. Okay, so performance is there. The hypervisor is obviously Hyper-V. It's running Windows Server 2008 R2 Service Pack 1. And they configured 4 VMs, each with 4 virtual processors and some RAM, and running those guest OSs were running 2008 R2 Service Pack 1 as well. So that was the configuration from a virtualization perspective. And they scaled using JetStress, which is hammering the I/O. So obviously there are other tools or other load simulation tools that you can run that would simulate users using ActiveSync and Outlook Web Access and so on. But JetStress is really about the I/O, and it's scaled linearly from 5,000 to 20,000 mailboxes across those 4 virtual machines. Now, that was 5,000 mailboxes per VM, 250 meg mailboxes, which is relatively small. So increasing those would probably reduce the number of mailboxes you were running. But in terms of the IOPS, it was, again, good performance. There are 2 databases and copies per virtual machine, so in line with what best practices are for physical Exchange as well. And again, in graphical format, 5,000 for 1 VM, up to 20,000 for 4 VMs. So great performance there across. Again, validating that virtualizing this key workload shouldn't be something that you're concerned about. Now, when it comes to response time, that was increasing as we got closer to the 4 VMs, up to the 20,000 mailboxes, but it was a very, very small increase, that very small line that's increasing up and up and up there. And then we go from looking at the individual mailboxes to the IOPS, the overall IOPS. And you see again, as we move towards 4 mailboxes, so spreading, scaling out Exchange. Remember, this is just on one Hyper-V host, so 4 VMs on the one host. We've got the just over 2,000, up to 4,000, 6,000, and then up to 7,000 IOPS. Again, very, very performant, linked in with the similar kind of performance stats we saw with iSCSI before. Don't be afraid to kind of go down that route. Is anybody aware of the Exchange-tested solutions? Just by show of hands. Okay, Exchange-tested solutions, this is where Microsoft works with server and storage vendors, so Dell or HP or NF5 and IBM and so on, to produce pre-validated configurations for things like Exchange. So if you're thinking, you know what, I'd like to go forward with a virtualized configuration of Exchange for this particular size, you see 500 mailboxes running on Dell, you see 9,000 running on Dell with Equalogic storage and F5 load balancing, right up to 32,400 across 3 sites running Hyper-V with Cisco, UCS, and EMC storage. So these pre-validated, documented solutions that you can look at and utilize to build out your own virtualized Exchange solutions. They cover the key decision points for common scenarios, things that you should be thinking about for this environment. Servers, storage, and networking, all configured in an optimal way. In terms of the documentation, it's all available from these links, so very, very useful indeed. There has been some documents just published for Exchange, actually. If I just pop back to my, my machine here very quickly. Very, very quickly. Around best practices for virtualizing Exchange with Windows Server 2008 R2 Hyper-V. Just literally been published. Okay, and this is available online. You can grab it from, and I can supply the links at the end as well. It'll be in the slides. Pull it down. It includes thinking about things like dynamic memory, storage, and so on. But just so you're aware, there has been a white paper published. It's 38 pages long. I'm not going to go through it now, starting from page 1. But it's certainly a useful read because not only does it cover the virtualization aspects, but it gives you some really useful information about Exchange in general, whether you are thinking about virtualizing or physical. And a lot of the considerations you make are very, very similar. Okay, so something to be aware of. Yes, it does, absolutely. Yeah. So the question was, does it cover failover? Yes, and we're going to touch on that later on anyway. So yeah, a number of different failover scenarios. So when you look at the Exchange-tested solutions, you see, again, similar results to what we've already shown. Linear scalability right up until 32,400 on the Cisco UCS. So if you're thinking about virtualizing up to that scale, and you think, well, do we invest in new platforms for this? Exchange-tested solutions might be a good place to start, okay, unless you want to do it yourself using the guidelines that are in the white paper and some of the stuff we've got covered today. And again, a bit more information about that, some of the relevant links. So solution 1, 9,000 mailboxes, right up to solution 4, which was over 32,000, across different sites with different levels of resiliency, because if you're going across split sites, obviously your design considerations are slightly different. How much RAM was in there? Over 1 terabyte of RAM total across that solution at the bottom there, and a lot of storage, a lot of mailbox VMs. So a total of 36 VMs was powering solution 4. But that's the kind of things you've got to think about. How many mailbox servers do I need? How many CAS servers? How many hub transport servers do I need? All of those things are important to consider. So just to summarize the Exchange results, we simulated 20,000 Exchange users on a single server in 4 VMs. Now in production, would you put those 4 virtual machines on the same host? And the answer is no. You'd separate them out for resiliency. You wouldn't have 2 members of the same DAG on the same physical host. You wouldn't do it because you'd be lowering the level of resiliency from a hardware perspective there. You'd want to separate these out and make these design considerations that we'll talk about shortly. And in terms of the 2011 results, it scaled to meet the I/O performance requirements of 20,000 mailboxes. The Exchange-tested solutions met the requirements of 9,000 through 32,000, and the scalability and low overhead of Hyper-V can be used in combination with Exchange. For so long, it's been one of those workloads with a do I, don't I approach, but now you can virtualize with confidence. Okay? So in terms of the best practices, what do we support with Exchange? A lot of people think, do I get more support running Exchange on Hyper-V than VMware? And the answer is no. If we flick over to my machine here, and I go to my Windows Server Catalog. How many people have used the Windows Server Catalog.com? Only 3 or 4. if you're evaluating hardware, if you're evaluating storage, if you're evaluating applications going forward for running Windows Server workloads, the Windows Server Catalog is a great place to start. But as part of that, there is a Server Virtualization Validation Program, abbreviated down to SVVP. And this is a really good place to go if you want to figure out, is my application or an application like Exchange or SQL or SharePoint or Dynamics, or you'll see there's a big long list, is this application supported on hypervisor X? Hyper-V, is it virtualized? Is it supported on Exchange? So we choose our application. So if we look at something like 2003, Service Pack 2, let's go next, running on vSphere ESXi 4.1. So this is important because the Server Virtualization Validation Program is there for us to work with vendors out there like VMware and Citrix and Red Hat and what was Novell SUSE and Cisco to say, you know what, we want to validate these platforms for key workloads like Microsoft stuff like Exchange and so on. So these vendors have to go through a number of tests to ensure that these workloads are supported on their platform. So it's good to have in your favorites if you're thinking about that. So what's the guest OS? We'll put it on 2003 SP2, 32-bit. I'm just choosing random ones here. This configuration, not supported. And the reason being is Exchange Server 2003 SP2 is only supported on Virtual Server 2005, not supported on hardware virtualization. However, if you did it on with Exchange 2007 or Exchange 2010 on VMware, with the right configuration, it would say supported and links off to relevant configuration options as well. So it's quite a useful wizard to use if you're going down this route. But going back to those support statements. So supported hypervisor, Hyper-V 2008, ideally R2 with Service Pack 1, or any third-party hypervisor validated via the SVVP program that I've just shown. And the Exchange VM can be configured as follows. It can be Exchange 2010, ideally Service Pack 1 for Exchange, which we'll see shortly, deployed on a guest OS of 2008, SP2, which is the latest Service Pack for Windows Server 2008, or Windows Server 2008 R2 with or without Service Pack 1. It doesn't, in terms of the unified messaging role, this is not supported virtualized on 2010 Exchange, but it is on 2010 SP1. Okay, that's an important note, something to consider. So if you want to virtualize the unified messaging role, you need to be running it on Exchange 2010 SP1. Okay? So we've seen some of these bits already. Oh, my deck's gone all over the place there. That's great. Did think I had quite a large number of slides. Oh yeah, the remote was upside down. There you go. Left hand, right hand. Right. There we go, there we go, there we go. Yeah, great, great, great. There we go. So storage. We've kind of talked about some of this stuff already. Fixed size VHD, SCSI or fixed size VHD, SCSI or iSCSI pass-through. And what that's saying is, fixed size VHD is going to give you the greatest level of performance for your key bits of your Exchange infrastructure. But if you do want to use pass-through disks, you can do that. And what a pass-through disk is a physical raw LUN or SCSI disk from inside the physical host, presented to the VM for its own exclusive use. You're not dropping VHDs onto it, you're using it exclusively. Now, there was a time with Hyper-V, perhaps in the 2008 days, when there was even still a slight difference between fixed VHD and pass-through disk. And for the utmost performance, people said, you know what, use pass-through disk. But you lose some of the flexibility that you gain with a VHD, being able to move it around more flexibly. In 2008 R2 and onwards, fixed size and pass-through are very, 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 very close together in terms of performance. So don't be afraid to use the virtual hard disk as opposed to a pass-through, but we support either. Exchange will also support iSCSI guest OS support. What I mean by that is, inside the guest operating system, you turn on the iSCSI initiator, and you hook that onto your iSCSI storage. But you can only use that with iSCSI. You can't use that with fiber, because there isn't a virtual HBA inside a guest operating system today. We don't support dynamic disks or thin disks. So if you're running VMware, a thin VMDK, we don't support that. If you want to do it, that's up to you, but it's not supported by Microsoft. Neither are differencing disks. And if you're not sure what a differencing disk is, if you create a master VHD and you create a child VHD off of that, that is a differencing disk. Okay, a lot of the reads are coming from the master. The differencing disk is where the changes go. That is not supported for Exchange. It's great for things like VDI and so on, where you want to reduce the total amount of storage you're using. not for workloads like Exchange. That would be a no-no. Other considerations. When it comes to the Hyper-V host, all that you should be running on Hyper-V is Hyper-V. Okay? Don't be running lots of other workloads, a domain controller, file and print server, and so on. It should just be Hyper-V. And don't combine the DAGs with Hypervisor HA in terms of on the local box. Okay? That's very, very important. Shouldn't be happening. Okay? Snapshots are not supported. And when you're thinking about your CPU ratios, the best practice is 1-to-1, so one virtual processor to one logical core, okay, on the physical host. So one core on physical, one virtual processor is best, but we do support 2-to-1. Now, when it says do not combine availability groups with hypervisor-based HA, that's for 2010. For Service Pack 1, we do support that. And that was a key thing that was brought in, a key note to make. Gone of that is that choice you have to make now where you've got Hyper-V cluster up to 16 nodes, and you want to cluster Exchange at the Exchange level as well. You don't have to make a choice of one over the other now. If you're running Exchange 2010 Service Pack 1 and you're running a Hyper-V cluster, you can combine those levels of availability. So you get the best of both worlds. But the big recommendation is do not run those DAG members on the individual physical node. You'd want to separate them out across the cluster, okay, to give you those multiple levels of resiliency. So when it comes to deployment recommendations, Exchange isn't virtualization aware. It doesn't know it's being virtualized on Hyper-V, on VMware, and so on. So the core design principles that you apply to Exchange, and they're covered in that white paper in a great amount of detail, still apply. They're still very, very relevant. They're still very, very important. So when you're sizing up your mailboxes, you'll still just use the normal mailbox sizing calculator that you would use for a normal physical Exchange. When you're sizing the usage profiles and how you distribute the CAS and the mailboxes and the messaging profile and the type of users that are going to be integrated and using this system, again, you'll design it in the same way. When it comes to virtualization, the key design considerations are locating things across these virtualization hosts and also making sure that you've got the affinity to not have multiple DAG members running on the same physical host and so on. So that's very, very important. But as I said, the design principles for virtualization are extra. So performance, ensuring you're using fixed VHDs. You've got the network throughput there. You're using things like 10 gig E if you can for both performance, reliability, and capacity. But they should be size specific to the role. So you've done your sizing for Exchange and you've determined that your mailbox servers need to be 16 gig of RAM and ideally 4 virtual processors. Then build your virtual machines for that size. As I said, Exchange is a workload that if you give it the 16 gig of RAM, it will utilize that memory and generate higher levels of I/O for performance and handle higher levels of I/O. Turning on dynamic memory, it's not a workload that will benefit from that, okay, for this particular workload. So when we look at some of the sizing guidance in there, it's a bit of an eye chart on that one. When you're looking at edge and hub, maximum processor sockets too, memory sizing, a gig per processor, all of these are related to the key stuff that we've pulled out from the physical guidance for Exchange. There are considerations to make. You may want to run virtual machines with 4 virtual processors, which is the maximum that Hyper-V supports. But as you get larger and larger and the different roles that apply, you're going to want to have to choose certain characteristics of these workloads. And you see we've got physical deployment on the left, virtual on the right, to match and the performance that we're demanding. But certainly the Exchange tested solutions and the guidance in the white paper are certainly going to help you with that. In terms of mailbox guidance, again, this is pulling it from the physical guidance as well. So you see here the send and receive 75K messaging sizes. So if it's 50, your cache per mailbox is 3, going right up to 500 down to 30. When it comes to virtual processors and logical processors, that one-to-one relationship will enable you to keep those high levels of performance. So very, very important. When you're scaling it out, don't think, you know what, I'm going to give every virtual machine, every Exchange virtual machine, 4 virtual processors, even though my host has only got a total of 4 cores. You'll become overcommitted from a CPU perspective. That won't be a good design decision from a performance perspective. As we said, when it comes to storage, I would use VHD if it's my choice because the performance of fixed VHD is very high. You can use pass-through if you want, but I would attach it to the secondary or the SCSI controller within the virtual machine. And what I mean by that is, if I go across to my virtual machine in here, and have a look here, you'll see this virtual machine here, I've just picked one at random. It's got a SCSI controller. It's got a virtual IDE controller where the native boot drive is attached, but this SCSI controller is where I can attach other hard drives as well, and it also supports hot add of storage as well, so I can add a hard drive on the fly while the guest is running. But that could be a virtual hard disk that I'm adding to it, or a pass-through disk. But either way, I would utilize the SCSI controller as that secondary point of attachment for the virtual machine. But if I look at a particular virtual machine I've got running already, let me just cancel out of there for a sec. At the moment, this machine has just a single drive, single virtual disk. However, if I want to attach more, I could turn on the iSCSI initiator in the guest. It's not running at the moment, but I can start that up and it'll open up the relevant ports in the firewall. And once that starts up, there we go. I've got the resolution of the VM very small, hence why that window doesn't quite fit in. But this is the iSCSI initiator that I could point from the VM straight through to my Exchange backend or my SAN backend and utilize the raw performance of the SAN coming straight through to the guest via the network. That's where 10 gig Ethernet or even 1 gig Ethernet is going to give you good performance there. But it needs iSCSI storage for that. Okay, it wouldn't work with fiber. Fiber is applicable to use with pass-through disks that we talked about before as well. Now, the reason I had this VM up as well, just looking at the network properties very quickly. And look at this is a virtual NIC within the guest operating system. And I look at the configuration and advanced. Now, although they're quite small to make out, the kind of things that you'll see in there, the properties of the virtual network adapter, jumbo packets, large send offload, TCP offload, these are characteristics of physical NICs that enhance performance. And we've got those inside the guest operating systems as well, so that you can connect to the physical infrastructure that's surrounding these virtualized hosts, hook it into your SAN, and get the high throughput that you would in the physical world as well. So you can tune those, you can turn them on. If you don't want them on, you can obviously turn them off inside the guest operating system as well. So that's where you would configure those. And again, for performance settings, that's certainly something that's pretty important. So in terms of a sample configuration, again, a bit of an eye chart, this one. HP have produced a 20,000 user config. I'm sure it's one of the tested solutions that you can have a look at across blades with an EVA SAN, so 16 VMs, 2 hub transports, 6 client access servers, 8 mailboxes, and you can see how they've distributed it and spread it out. And that's a good example of best practice where they've not combined stuff in such a way that if one host goes down, we lose a whole DAG. If one host goes down, we lose all of the client access servers and so on. They've really separated it out, which is really, really important, just as you would in the physical world. Okay, and in terms of the CPU's configuration, mailbox to CAS is a 4:3 ratio, whereas mailbox to hub transport is 5:1, so 5 mailboxes to 1 hub transport. But then again, that's utilizing the best practices from Exchange specifically. Then we come to DAGs, and DAGs are Exchange's native high availability solution, okay, in 2010, and enhanced obviously in Service Pack 1. You could have a group of up to 16 of these DAG mailbox servers that provide in that level of resiliency that's very fast. If you compare it with something like a Hyper-V or a virtualization failover, the speed at which DAG can respond to an outage is much quicker than what a failover of a virtual machine would be. Okay, so if you've got a single Exchange mailbox server on a Hyper-V cluster and one of your Hyper-V nodes fails, that mailbox is going to take a little bit of time to come back up as it reboots the VM and starts back up again. If you've got a DAG group, one node on one Hyper-V host, one node on another, and one Hyper-V host goes bang, that DAG group will automatically respond incredibly quickly. So your users aren't going to suffer any outage there, whereas that other virtual machine is now going to reboot in time. So it's utilizing the native stuff with Exchange and benefits of the native data protection that exists in Exchange. But now, as I've said, with Service Pack 1 for Exchange, combined with Hyper-V, you can get the best of both worlds. So you can have that level of failover and the Exchange protection and availability and be supported. So before, with Exchange 2010, you wouldn't have been supported. Now you are. Okay, very, very important. So when it comes to clustering, this is what we've touched on before. Failover clustering built into Windows Server 2008 R2, and it was obviously in 2008 as well. it's important to understand that clustering isn't the only solution, as we've just talked on. That integration with the DAG at the Exchange layer is equally important. Now, in terms of what my environment looks like, if I just spin up my failover cluster manager here, bring it across. I've got my cluster, I've got 2 nodes in my cluster, I've got lots of things highly available on there. 2 of those things could be 2 DAG members. Okay, so 2 mailbox servers. If I lost 1 node in my cluster, those workloads would fail over to another available node. Okay? But the DAG would also work with that in terms of providing a quicker level of resiliency as well. But HA, as I've said for Hyper-V, it doesn't protect against anything to do with the mailboxes, any misconfiguration, any network failure at the VM level. It doesn't protect for those kind of things. Okay, it's just if the host fails. Now, VMware have a technology that is built into vSphere, some of the more advanced SKUs, so Advanced Enterprise Plus, that's called fault tolerance. And this keeps VMs, 2 VMs, in lockstep. Okay, so you have a VM on one host, a VM in another host, and they're not mirrored is the wrong word, but they're kept in lockstep. So if something happens to the VM on node 1, VM on node 2 will show that same error or same change or whatever. And you think, okay, would that mean that I don't even need to use the Exchange availability solutions? That sounds amazing. You know, that would be brilliant, because I wouldn't need Exchange clustering, because the replica of that VM is instantly running, and if I lost the host, this VM would instantly take over the running of that workload, that Exchange workload. No Exchange clustering needed. That sounds brilliant. That's a nirvana. The big caveat is only single processor virtual machines are supported, which for Exchange and workloads of that kind, where processing and memory is really important, that's not going to really cut it. So it's not for those mission-critical workloads yet. I would suggest strongly DAGs with Exchange, but also Hyper-V clustering, providing you're using Service Pack 1 for Exchange. Now, when it comes to live migration, this was introduced in Hyper-V R2, the ability to move virtual machines around. No problem. You can do that. But just be aware, you don't want to be moving virtual machines to compromise the layout of your Exchange infrastructure. What I mean by that is, if you separated those DAG groups from a design perspective, the last thing you want to do is start live migrating DAG members onto those individual hosts, because you're going to compromise the availability of Exchange. You want to keep them separate and use the relevant affinity and tools that exist in things like System Center to enhance that. So there is a single source for all of this information. So it's on TechNet. The white paper is also linked from there. The SVVP wizard is pretty good to utilize, but always check with TechNet just to make sure. As I said, Service Pack 1 and that white paper give all of the relevant information we've got around how to virtualize Exchange, best practices, and it's in much more detail than I would have time to go through in 75 minutes. So if you leave with anything today, definitely grab that particular white paper, because it's very, very worthwhile. And it's bang up to date, bang up to date, including the Service Pack 1 related things. So here's a quick reference, just to post back. Hyper-V, just run Hyper-V in that host. Remember the networking guidance I said? What was the minimum NICs that I said in a host? 6 for fiber, yep, that's it. Correct, sir, correct. I don't have any prizes. There is a book up here, but it's not mine. I wouldn't want to give it out, just in developing SharePoint, but that's correct, yeah. 8 is the minimum. Whether you're using iSCSI, whether you're using fiber, I would recommend using fixed size VHDs over dynamic. Definitely a big consideration. How many people are running Exchange 2010 today, or evaluating going to it? How many people have got Service Pack 1 on there? Okay, good, excellent. So if you haven't, I would certainly factor into your design process going forward how I can get to Service Pack 1, because whether you're running it on VMware, whether you're running it on Hyper-V, or whatever, it's certainly in your interest to put Service Pack 1 on and gain the support for the dual levels of availability there. You're setting yourself up for a greater level of resiliency and availability. So how can we enhance the story? And this is where I've got some kind of brief demos as well, because the System Center stuff is really where you can start to glean the extra knowledge and value from Exchange. I can put in the best infrastructure for Exchange in the world and virtualizing it follow the exact guidelines that are in the white paper. But if something goes wrong, or users start to complain about something not quite happening as it should, how do I know what to troubleshoot? Do I go to Event Viewer? Is that where I spend my evening? Having a look through those kind of things. That's painful. So tools that exist within System Center can really help with that. Is anybody using DPM to protect Exchange? Brilliant, excellent. And DPM 2012 is only going to enhance that. But DPM 2010 protects Exchange up to every 15 minutes, just the change blocks. And the nice thing is it understands things like DAG. So you don't have to treat it, especially with kid gloves, to protect those kind of workloads. So it'll allow you very quick protection of those workloads and restoration. But one thing not a lot of people know about with Data Protection Manager, if I flick over to mine, is there is a feature within DPM 2010, I think it was in previous versions as well. I'm not going to go through because my two sites, one of my sites in the MTC in Reading is being completely rebuilt, so it's down at the moment, so I'm not going to show a live demonstration of this feature. But it's something called DPM to DPM for DR. Now you can acronymize it, if that's such a word, as I've got here, DPM to DPM for DR, like I was texting it. But DPM to DPM for DR, because we give away the DPM server, the actual server that's doing the backup jobs, you can put them all over the place if you want. And DPM to DPM for DR, imagine the scenario. I've got a site in Seattle. I've got a site in Las Vegas. So I've got two sites separated by a geographical boundary. Seattle is my main site where all of my Exchange stuff lives. And I could be backing that up with DPM on site, backing up the DAGs and all the different bits and bobs to restore from disk or even to back up to tape if I want. But in Las Vegas, which is our DR site, I've got another Data Protection Manager server that I'm pointing at DPM in Seattle and backing it up across the wire. Just the change blocks, just the delta changes, very efficient. If that initial replica is massive, I can send it via post if I want to, as a manual replica. But what that's enabling me to do is, in the event of a disaster in Site A, restore in Site B. Now, obviously, if you're using Exchange with its levels of availability that are built in, you may separate your DAGs across that geographical boundary. It's up to you, depending on your design considerations. But DPM to DPM for DR is a really low cost but really efficient way of protecting one site and backing up to another. And although my second site is down at the moment, you can see what I was protecting on that second site. I was protecting Exchange mailbox data, the back end of DPM as well. So if I did lose Reading, which I have done, in fact, in this case, Reading is down, I could restore all of my Exchange infrastructure onto this second site if I wanted to do that. And that's a feature that's built into DPM at no cost. Okay, so DPM to DPM for DR. But then we come on to some of the other System Center tools that can really provide us big amounts of value. And that's where Ops Manager comes in. Now, the nice thing about Ops Manager is the management packs that allow us to monitor stuff, i.e. SQL, SharePoint, Exchange, Hyper-V, IBM hardware, Dell hardware, you name it, they're written by the teams that make those products. So the Ops Manager team aren't out there racking their brains thinking, what is best to monitor with Exchange? I really don't know. Do I just monitor these bits or those bits or whatever? And that's where the Exchange team bring in their management packs. Okay, they write their management packs. And the management packs cover all of the different areas of Exchange, from alerting to performance, across client access, edge transport, hub transport, mailbox, unified messaging. Okay, so it's understanding and monitoring all of those different components at the different levels and alerting on them in a relevant way. But the nice thing is when you do get alerts about things in System Center Operations Manager, it comes packed with lots of useful information as well. So if we have a look at, I'll choose one in particular. Let's choose this one. Hopefully this will come with some useful information. Product knowledge. That gives me a bit of information about the AD replication partner. Let me choose another one. Properties. Let's go to Open Health Explorer. So Health Explorer is a tool within Ops Manager that drills down and shows us where the stuff that's going wrong is based on that particular server. You see there's quite a few bits and bobs. We'll click this one here. In fact, this one that's wrong. So this is saying, in Data Protection Manager, when the disk space is used for a specified replica has exceeded a recommended threshold, we're going to give you an alert. That's just one example. I'm not trying to pull out that particular alert in general, but just the fact that it gives you a summary of what's gone wrong, what can cause that, and what kind of resolutions are that you can perform as an IT admin. And that's the same kind of thing that exists in the Exchange Management Pack, SQL, SharePoint. We're just trying to make it easier for you to make more informed decisions should something go wrong or start to go wrong. So you know that, for example, before a user rings up and says, Outlook web access is going really, really slow, you know, what's going wrong? You know because you've got Ops Manager doing synthetic transactions against that Outlook Web Access, acting as a user, and you've already found out that it's going slow, and you've traced the problem back to what's causing that, and you can start to rectify the problem more quickly. So that knowledge that's in Ops Manager is very, very powerful. And the way you can diagrammatically visualize the different elements of your infrastructure, so things like, if you look at my Dell hardware that's in my infrastructure, here it comes, it's just refreshing. I've got a few hosts. I've got my 2 cluster nodes, Hypernode 1 and Hypernode 2. I've got another standalone node as well, and that refreshes. And this allows me to visualize my server hardware in the form of what's known as a distributed application when it comes up. Here we go. There we go, lovely. So this is my Dell Blade infrastructure, or my rack infrastructure in this case, actually. And I can drill down, expand these out, and I'm getting Dell-related tasks down the side here. So this is a key feature of Ops Manager. Moving down, moving down, moving down. And I can go right down inside the NICs, inside the memory DIMMs, and so on, and see just where the problems may or may not be occurring. So if my Exchange email infrastructure is relying on some of these different component parts, I can quickly and efficiently build distributed applications that map to that. So I could build an email infrastructure distributed application view. And in ours, we've got some ones that are reflected. Let me just go to authoring. Let me have a look at... so we've got really important app and really, really important app. But if we have a look, we're not very good on the old naming terminologies. But if we look at this particular view, which is really, really important app, we'll see that this is made up, and this is one that we've built ourselves, and it's made up of a number of different components. It's made up of authentication with Active Directory. It's relying on some hardware, relying on a database, relying on a web front end. You can build these very quickly and efficiently, export to Visio if you want, nice touch. But what they allow you to do is represent something almost like a service. So really, really important app is really, really important to the business. But our business decision owners or our decision makers are only interested in really, really important app. They're not interested in the nuts and bolts and the memory DIMMs that are making up that particular infrastructure. And how we can continue to visualize that to our people within our environments is through dashboards like this. So a richness, a way of displaying the information in a nice, intuitive way. Okay? So that is what I want to show there. So DPM Ops Manager working together to monitor and protect key workloads like Exchange. Virtual Machine Manager doesn't really play a part natively with Exchange, but it can certainly speed up the provisioning of virtual infrastructure to host Exchange. And if you combine it with some of the automated scripts that exist available to deploy Exchange in an automated fashion, you could actually rapidly and in an automated way deploy Exchange Server. Because VMM includes some capability known as templates. A template is used to rapidly provision a virtual machine, a guest OS. But if you've got the Exchange binaries in there and some custom scripts to deploy on a run once command, when you deploy that template the first time, it'll trigger those scripts and it'll deploy Exchange as part of the install process. So a nice rolled up scenario there. That's not native in terms of integration. That's something you would have to work at, but it's certainly quite feasible today. But that's where we start to integrate with System Center. But also our partners in Citrix. So if anyone uses load balancers in front of Exchange, so to ensure that our users are getting a rich experience when accessing things like Outlook Web Access or the transports and whatnot, the Hyper-V virtual appliance, the VPX is a Hyper-V virtual appliance deployed through VMM, and it speeds up those deployment of those templates and configuration wizards. And it's got wizards within it specific to Exchange. I would like to load balance Exchange. Okay, you need to do all of these things. Next, 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 finish. So it's really designed with these core Microsoft workloads in mind. And it load balances those client access servers once it's launched. So 3 real easy steps. In fact, 4 steps. All right, I'll tell a lie. 4 steps. Number 1, download the VPX. And I think you can download an Express edition for no cost. Pull it down from Citrix. Deploy it through VMM with the relevant CPU and stuff it needs. Open it up. Configure it for Exchange using the wizards, and once it's deployed and pointed at the relevant client access servers, you've got a very quick load balance solution. Okay, very, very cost effective and in tune with your virtualized infrastructure. And the nice thing is it ships with a management pack for Ops Manager, so we can monitor it. And it's not just any old management pack. This is a pro-enabled management pack, which means should it determine that there are a situation within the infrastructure that's could impact our virtual machines. Maybe some hardware is starting to have a problem, or the load balancer is getting saturated on one particular route. Maybe we should move some virtual machines around automatically to counteract that particular problem we're experiencing. And that's what the Pro enablement is really all about. It's about bringing around movement or changes to virtual machines based on changing conditions in the environment. So having a Pro-enabled management pack is really, really worthwhile. Other vendors who do Pro-enabled management packs, F5, Dell from a server perspective, NetApp from a storage perspective, EMC have got one as well just down there on the booth. So all of those are bringing out these Pro management packs that just extend the value if you're a joint customer of theirs and ours. We've talked about some of the evidence that exists, so sizing guidance, the exchange tested solutions and stuff, they're all available, so please feel free to grab those or come up and have a chat about them if you want to know a little bit more, and I can point you in the right direction. And there are lots of other resources this week. There's a great session that I think it's already taken place, so it will be recorded, on a deeper dive into the exchange side of things, because we had to cover an equal amount of Hyper-V as well. They just focus purely on exchange, so you may find that additionally useful. But certainly come down and see us on the booth as well, and thank you very much for your time.